This screencast provides an introduction to time series analysis. The screencasts in this entire module will provide an overview of the material. You'll need to work through the material to learn it. This page provides an overview of forecasting methods. Qualitative forecasting methods include, for example, the Delphi method. The Delphi method gathers a team of experts and applies an iterative team process to create a forecast of a future event. Quantitative forecasting methods. Quantitative forecasting methods have the primary task of determining an appropriate forecasting model. They make the general assumption that the future will behave like the past and apply the model selection idea that if a model is going to have a reasonable chance of predicting the future, it must fit past data. There are two general types of quantitative forecasting methods. Time series forecasting methods include, for example, forecasting next week's sales based solely on the time series of weekly sales over the past 104 weeks. Causal forecasting methods include time series forecasting methods, but are a bit more general. For example, a forecast of next week's sales can be based on the time series of past weekly sales as well as a second time series of weekly advertising expenditures. Generalizing time series methods to encompass causal forecasting methods is straightforward, but it would take more time than the 2 weeks we have remaining in this course. Modules 7 and 8 are only about time series forecasting methods. The next section introduces the 4 components of a time series. The trend component refers to, for example, the long-term increase in the time series variable. The seasonal component refers to the predictable oscillation of the time series variable about its trend line that occurs over a 1-year period. The cyclical component refers to a predictable oscillation that occurs over a period of more than 1 year. And the random component, also known as the irregular component or the random noise component, is similar to the random error that occurs in regression models. A time series that exhibits only a random component is called a stationary time series. It is fundamental when studying a time series to always begin by making a time series plot of the data. The choice of period over which time series data is aggregated can allow different components of a time series to be observed. When feasible, studying time series plots with the data aggregated over different periods, for example, days, weeks, months, quarters, or even years, can expose different characteristics of the data. An example involving billing data for a consulting firm. This column refers to the year 2010, 2011, 2012. This column refers to the quarter of the year, so the first quarter of 2010 through the fourth quarter of 2010. The fifth quarter is actually the first quarter of 2011 down to the last quarter of 2011. The ninth quarter is the first quarter of 2012, etc. The quarterly billing data in thousands of dollars is in this column. So the first quarter of 2010 involved the billing of $560,000, and the fourth quarter of 2012 involved billing of $2,220,000. When the quarterly billing data is summed, we get an annual billing amount. So summing these four quarterly billing amounts, we get $3,060,000 was billed in 2010. And for the four quarters of 2011, the annual billing was $4,880,000. And in 2012, the four quarters sum gives an annual billing amount of $6,960,000. We've moved to the next page. The first plot indicates the three annual billing amounts. In the plot, we see clearly the positive linear trend in the data. The annual billing amount increases by approximately the same amount each year. It's not until we plot the quarterly data, however, that we observe the seasonality component of the time series. The dashed trend line here is the simple linear regression line with quarter as the independent variable. We can see from this plot of quarterly data that the second quarter of each year tends to be below the trend line, and the fourth quarter of each year tends to be above the trend line. Here's a straightforward use of a time series plot designed to influence human behavior. I'll let you read this example, but we'll mention another. In the flying business, taxi accidents are almost always contributable to pilots directing their attention from outside the airplane. For example, at the end of a long flight, there's a tendency to lose focus as the airplane pulls off the runway. It's at this time that taxi accidents are most common. Posting a monthly time series of the number of taxi accidents at all airports reminds air crews of the importance of staying focused after landing. And this simple display has been associated with a significant reduction in taxi accidents. I've moved to the next page. Control charts are another example of time series. You will spend time constructing and applying control charts in Business 604, Operations Management. This is an introductory example. The first chart is an R or range chart. The second is an X bar or mean chart. Three features of a control chart include the center line, indicated as R bar on the first chart, and X bar on the second chart, the upper control limit, UCL, indicated here on the range chart and here on the X bar chart, and the lower control limit, LCL, here on the R chart and here on the X bar chart. The numerical values of the CL, UCL, and LCL are determined while the process is being closely monitored and is known to be under control. The process being monitored in this example is the delivery time of luggage at an upscale hotel. You should read this example. A process is deemed to be out of control whenever a dot is observed to be above the upper control limit or below the lower control limit. A process is also considered out of control when 5 consecutive observations appear on one side of a center line. Whenever a process is deemed out of control, appropriate action is taken immediately. This will complete this screencast.